So when we are describing how each layer of Earth evolved and formed, we have to think about temperature and density. So density and composition were two driving factors of Earth separating into layers. And as temperature increases, our density will always decrease. I like to think of this as the lava lamp. The lava lamp idea of early Earth. So when my temperature decreases, when my temperature goes down, density will go up. So these are opposites. And we had Earth, and we had the first Earth was uniform, very high temperature, and then we had our first little pieces of iron and nickel that formed. And if something is more dense than its surroundings, it will sink. So iron and nickel began to sink into the center of the Earth because that is essentially the bottom of the Earth. So iron and nickel began to accumulate in the core. And over time, we see Earth have the layers like present day. So we have our solid inner core, liquid outer core. We have the mantle, and then we have the crust. Okay, so not very good at drawing circles. I think you get the idea. So iron and nickel accumulated in the core. And when material is under so much pressure from all sides, even if it's very hot, it forms a solid rather than being a liquid. So that's why we have a solid inner core, and our inner core is composed primarily of iron. It's an iron nickel alloy, so a combination of iron and nickel, mostly iron. And then we have a liquid outer core here, and our liquid outer core convects. We'll talk about heat transfer and convection, but basically it's moving around because of its high temperature, and it's a liquid, so it's going to be moving and convecting like you'd have a convection oven. The air inside the oven convects and moves in circles, or in convective cells is what we'd call that. So our iron and nickel accumulated in the core. We have an iron liquid outer core, and then we have the mantle. The mantle's a little more complicated. We're going to get to that. And then we have a crust. So those are our primary layers of Earth. And if we look at the mantle here, so let's say this is just the mantle. We have two separate areas. So I'm just lumping the core, inner and outer, together. And I have an upper and lower mantle. And the upper mantle is rigid, and the lower mantle is able to move. So our lower mantle actually can convect even though it's still a solid. It's under enough pressure and high enough temperature that it can move. And this rigid upper part, including the crust, is moved by these convective cells.